We all experience changing states of consciousness each day, varying levels of awareness of ourselves, our behavior, and the world around us. We shift from operating on automatic while driving a car, combing our hair, or brushing our teeth to full and careful attention to tasks we find challenging, either mentally or physically. And when we go to sleep at night, perhaps to dream, or take some drug that affects the way we feel, we may also experience dramatic shifts in consciousness. The existence of these different states of consciousness raises many intriguing questions. Can we really do two or more things at once? Why are we more alert and energetic at some times during the day than at others? What causes jet lag? What happens when we fall asleep and dream? In addition, many other questions about the nature and processes of consciousness have been raised from modern disciplines like artificial intelligence, biology, and physics, but also from indigenous thought systems like Vedanta and Samkhya. Indeed, the study of consciousness poses a complex puzzle. While the focus of this chapter is limited, it is pertinent to understand the various facets of cognition. When do you feel most alert and energetic? Whatever your answer, it's clear that most of us do experience regular shifts in these respects each day. Psychologists and other scientists refer to such changes as biological rhythms, regular fluctuations in our bodily processes and in consciousness over time. Many of these fluctuations occur over the course of a single day and are therefore known as circadian rhythms, from the Latin words for around and day. Other fluctuations occupy shorter periods of time. For instance, many people become hungry every 2 or 3 hours. And still other cycles occur over longer periods, such as the mating seasons shown by many animals. They mate only at certain times of the year, and the human female menstrual cycle, which is roughly 28 days. Most people are aware of fluctuations in their alertness, energy, and moods over the course of a day, and research findings indicate that such shifts are closely related to changes in underlying bodily processes. Daily cycles occur in the production of various hormones, core body temperature, blood pressure, and several other processes. For many persons, these functions are highest in the late afternoon and evening, and lowest in the early hours of the morning. Large individual differences in this respect exist, however, so the pattern varies greatly for different persons. In addition, circadian rhythms seem to shift with age. As people grow older, their peaks often tend to occur earlier in the day. If bodily processes, mental alertness, and performance on many tasks change regularly over the course of the day, it seems reasonable to suggest that we possess some internal biological mechanism for regulating such changes. In other words, we must possess one or more biological clocks that time various circadian rhythms. While there is not as yet total agreement on the number or nature of these internal clocks, existing evidence points to the conclusion that one structure, the suprachiasmatic nucleus, SCN, located in the hypothalamus, plays a key role in this respect. Often we perform two tasks at the same time, for example, brushing our teeth while our thoughts wander far and wide, or talking to another person as we cook some dish. How can we do this? The answer involves the fact that we have two contrasting ways of controlling ongoing activities, different levels of attention to, or conscious control over, our own behavior. The first level uses very little of our information processing capacity and seems to occur in an automatic manner with very little conscious awareness on our part. For this reason, psychologists refer to it as automatic processing, and it does seem, subjectively, to be automatic. In contrast, controlled processing involves more effortful and conscious control of thought and behavior. In controlled processing, you direct careful attention to the task at hand and concentrate on it. Processing of this type consumes significant cognitive resources. As a result, only one task requiring controlled processing can usually be performed at a time. What do you do when you pass a mirror? Probably you stop, however briefly, and check your appearance. Is your hair messed up? Your hat on straight? Your makeup, okay? When you engage in such activities, you are, in a sense, changing your current state of consciousness. Before you passed the mirror, you were probably thinking about something other than yourself. But while you stand in front of the glass, your thoughts are focused on yourself. Psychologists term this focus, self-awareness, and they have found that entering this particular state of consciousness has interesting and widespread effects. One question about self-awareness that comes readily to mind is, why do we enter this state to start with? The answer seems to be that some situations induce us to do so. Passing a mirror is one, speaking to or performing in front of an audience is another, and having our picture taken is yet another. In these situations, we are induced to think about ourselves. And once we do, an interesting process is initiated. According to one theory of self-awareness, control theory, when we focus our attention on ourselves, we compare our current state, our feelings, thoughts, and performance, to internal standards, how we would like to feel, think, and perform. If the gap is large, however, we have two choices. One, we can shape up, changing our thoughts or actions so that they fit more closely with our standards and goals. Or 2, we can ship out, withdraw from self-awareness in some way. Such withdrawal can range from simple distraction, we can stop thinking about ourselves and how we are falling short of our own internal standards, to more dangerous actions, such as drinking alcohol, engaging in binge eating, or, in the extreme, ending our own existence through suicide. People show one kind of self-awareness, awareness of their own inner thoughts and feelings, known as private self-consciousness, when induced to experience reflective moods such as sadness or contentment, but do not experience increased self-awareness when induced to experience socially oriented moods such as being thrilled or being angry. Still, another type of self-awareness involves the tendency to focus on our public image, how we appear to others. This is known as public self-consciousness. People who know themselves well are less likely to go off the track, psychologically. Yet, surprisingly, research on private self-consciousness, one of the 2 types of self-awareness we've considered, indicates that the higher people stand on this dimension, the less well-adjusted they tend to be. How can this be? One answer provided by recent research is as follows. When individuals focus on themselves, they may do so for 2 different motives. First, self-awareness can be motivated by curiosity, the desire to know oneself better. This is known as reflection. Second, self-awareness can be motivated primarily by fear, by concern over threats, perceived shortcomings, losses, or injustices one has experienced. This is known as rumination. Recent evidence indicates that rumination, but not reflection, is related to distress and several psychological problems. So thinking about ourselves can produce psychological benefits or psychological costs, depending on the motivation behind this activity and the topics on which we focus. To find out where you stand with respect to these aspects of self-awareness, what single activity occupies more of your time than any other? You may be tempted to say studying or working, but think again. The correct answer is probably sleep, a process in which important physiological changes and slowing basic bodily functions are accompanied by major shifts in consciousness. In fact, most people spend fully 1/3 of their entire lives asleep. What is the nature of sleep? What functions does it serve? And what are dreams? These are key questions on which we'll focus. As shown here, there are 4 distinct stages of sleep, each characterized by changes in the electrical activity of our brains. In addition, another phase of sleep, REM sleep, is markedly different. During REM sleep, activity in our brains closely resembles, in some respects, the activity that occurs when we are awake. Sleep serves mainly a restorative function, allowing us, and especially our brain, to rest and recover from the wear and tear of the day's activities. Several findings provide indirect evidence for this suggestion. First, if sleep allows our brain to rest, then we would expect to see more delta, slow-wave activity in portions of the brain that have experienced intense activity during the day. Some species of marine mammals show a pattern in which the 2 cerebral hemispheres take turns sleeping. This suggests that sleep does permit the brain to rest in some manner. A second possible function of slow-wave sleep emphasizes the relationship of sleep to circadian rhythms. According to this view, sleep is merely the neural mechanism that evolved to encourage various species, including our own, to remain inactive during those times of day when they do not usually engage in activities related to their survival. Turning to REM sleep, some findings are consistent with the view that these special phases play a crucial role in learning, in allowing us to consolidate memories of the preceding day, or, perhaps, to eliminate unnecessary memories and other mental clutter from our brains. Japanese scientists at ATR Computational Neuroscience Laboratories have developed a technology that uses functional magnetic resonance imaging, fMRI, and artificial intelligence, AI, to reconstruct visual dream content, achieving around 60% accuracy in identifying dream elements and over 70% for specific objects and faces. This early-stage system creates video-like sequences of dreams by analyzing brain activity and linking it to a database of images. While not a perfect playback, this breakthrough offers potential insights into mental health, consciousness, and how the brain functions during sleep. What is the most dramatic aspect of sleep? For many persons, the answer is obvious. Dreams, the jumbled, vivid, sometimes enticing, sometimes disturbing images that fill our sleeping minds. What are these experiences? Why do they occur? Let's first consider some basic facts about dreams, then turn to the answers to these questions provided by psychological research. Does everybody dream? The answer seems to be yes. Not all people remember dreaming, but EEG recordings and related data indicate that everyone experiences REM sleep. How long do dreams last? Many people believe that dreams last only an instant, but in fact, they seem to run on real time. The longer dreams seem to last, the longer they really are. Can external events become part of dreams? Yes, at least to a degree. For example, Dement and Wolpert sprayed water on sleepers who were in the REM stage of sleep. When they woke them up, more than half the sleepers reported water in their dreams. When people cannot remember their dreams, does this mean that they are purposely forgetting them, perhaps because they find the content disturbing? Probably not. Research on why people can or cannot remember their dreams indicates that this is primarily a function of what they do when they wake up. Do dreams foretell the future? There is no scientific evidence for this widespread belief. Do dreams express unconscious wishes? Again, there is no convincing scientific evidence for this view. Now that we've considered some basic facts about dreams, let's turn to several views concerning their nature and function. Let's begin with the idea that dreams express unconscious wishes or impulses. This view has existed for centuries, but its influence was greatly increased by Sigmund Freud, who felt that dreams provide a useful means for probing the unconscious thoughts, impulses, and wishes that lie outside the realm of conscious experience. In dreams, Freud believed, we can give expression to impulses and desires we find unacceptable during our waking hours. Thus, we can dream about gratifying illicit sexual desires, or about inflicting painful torture on persons who have made us angry, thoughts we actively repress during the day. Freud carefully analyzed the dreams of his patients, and he reported that in this manner he frequently gained important insights into the causes of their problems. So fascinating were his reports of these experiences as a therapist, and so filled with conviction, that many people quickly accepted Freud's claims. And such beliefs about the meaning of dreams are definitely alive and well today. Despite this fact, they are not supported by convincing scientific evidence. On the contrary, Freud provided no clear-cut rules for interpreting dreams and no way of determining whether such interpretations are accurate. In view of these facts, few psychologists currently accept the view that dreams offer a unique means for exploring the unconscious. Instead, most accept one of the views we will now consider. If dreams aren't reflections of hidden wishes or impulses, what are they? An answer is provided by what is sometimes known as the physiological view of dreams. According to this perspective, dreams are simply our subjective experience of what is, in essence, random neural activity in the brain. Such activity occurs while we sleep, simply because a minimal amount of stimulation is necessary for normal functioning of the brain and nervous system. Dreams then simply represent efforts by our cognitive systems to make sense out of this random neural activity. A logical extension of this view suggests that the activity of which we try to make sense is not actually random. Rather, it occurs primarily in the two systems of the brain that are most active when we are awake, the visual system and the motor system. As this view suggests, dreams are usually silent, but are filled with visual images. And although many dreams contain images of movement, few persons report experiencing smells, tactile touch, sensations, or tastes in their dreams. Another, and closely related, explanation of dreams carries somewhat farther these suggestions concerning our cognitive system's efforts to interpret neural activity while we sleep. This perspective, proposed by Antrobus, 1991, suggests that two facts about REM sleep are crucial to understanding the nature of dreams. 1. During REM sleep, areas of the cerebral cortex that play a role in waking perception, thought, and regulation of motor processes are highly active. 2. Yet at the same time, during REM sleep there is massive inhibition of input from sensory systems and muscles. These are suppressed. As a result, Antrobus, 1991, reasons, the cortical structures or systems that normally regulate perception and thought have only their own activity as input. The result is that this activity forms the basis for the imagery and ideas in dreams. Does this mean that dreams are meaningless? Not at all. Since they represent interpretations of neural activity by our own brain, dreams reflect aspects of our memories and waking experience. Convincing evidence for this connection between dreams and important events in our lives is provided by the fact that many persons attempting to make important changes in their own behavior, for example, to quit smoking or drinking, report having dreams of absent-minded transgression, damn it dreams for short. In such dreams, people suddenly notice that they have carelessly or absent-mindedly slipped into the habit they wish to break. They are smoking or drinking without having planned to do so. This realization leads to feelings of panic or guilt in the dream. In many cases, the dreamer is awake at that point, feeling quite disturbed. Interestingly, having such dreams is positively related to success in breaking the habits in question. Let's begin with some basic definitions. First, what are drugs? One widely accepted definition states that drugs are compounds that, because of their chemical structure, change the functioning of biological systems. Consciousness-altering drugs, therefore, are drugs that produce changes in consciousness. Suppose you went to your medicine cabinet and conducted a careful inventory of all the drugs present. How many would you find? Unless you are very unusual, quite a few. Many of these drugs probably are perfectly legal and can be obtained in any pharmacy without a prescription, for example, aspirin. Others are probably ones prescribed by a physician. Using drugs in both categories is generally safe and appropriate. The term drug abuse, therefore, applies only to instances in which people take drugs purely to change their moods, and in which they experience impaired behavior or social functioning as a result of doing so. Wallace and Fisher, 1987. Unfortunately, when people consume consciousness-altering drugs on a regular basis, they often develop dependence. They come to need the drug and cannot function without it. Two types of dependence exist. 1. Physiological dependence occurs when the need for the drug is based on organic factors, such as changes in metabolism. This type of dependence is what is usually meant by the term drug addiction. However, people can also develop psychological dependence, in which they experience strong desires to continue using the drug even though, physiologically, their bodies do not need it. As we'll soon see, several psychological mechanisms probably contribute to such dependence. Physiological and psychological dependence often occur together and magnify individuals' cravings for and dependence on specific drugs. Continued use of a drug over a prolonged period of time often leads to drug tolerance, a physiological reaction in which the body requires larger and larger doses in order to experience the same effects. For example, I once had a friend who drank more than 20 cups of coffee each day. He didn't start out this way. Rather, he gradually increased the amount of coffee he consumed over the years until he reached the level where, we joked, he sloshed as he walked. In some cases, tolerance for one drug increases tolerance for another. This is known as cross-tolerance. Putting trends in drug use aside for the moment, a more basic question exists. Why do people take consciousness-altering drugs in the first place? Several psychological mechanisms seem to play a role. First, and perhaps most obvious, people often use such drugs because doing so feels good. In other words, the effects produced by the drugs are somehow rewarding. Evidence supporting this view is provided by many studies indicating that animals will self-administer many of the same drugs that people abuse, presumably because they find the effects of these drugs rewarding. Another perspective suggests that drug abuse can be understood largely in terms of social factors. According to this view, individuals, especially adolescents and young adults, use consciousness-altering drugs because it is the in thing to do. Their friends use these drugs, and they believe that if they do too, this will enhance their social image. Evidence for this view has been reported. In many studies, it appears that social motivation is a powerful factor in drug abuse, especially by young people. The distinction between automatic and controlled behavior forms the basis for yet another perspective on drug abuse. According to this view, the cognitive systems controlling many aspects of obtaining and consuming various drugs may soon take on the character of automatic processes. To the extent that this occurs, drug use becomes quick and relatively effortless, occurs without conscious intention, is difficult to inhibit, and may even take place in the absence of conscious awareness. Once individuals have used a drug on numerous occasions, then they may find themselves responding almost automatically to external cues, for example, to a specific environment in which they have often enjoyed this drug, such as a bar, or to specific sights and smells, such as the aroma of a burning cigarette. In a similar manner, they may respond automatically to internal cues or emotions, such as wanting to celebrate or feeling tired or out of sorts. These cues may trigger people's tendencies to use drugs, and they may find themselves doing so before they realize it, even without any strong urge to take a drug. Which of these perspectives is most accurate? Most psychologists favor a view that combines the learning, social, and cognitive perspectives. Drug abuse, it appears, stems from a combination of factors, and this sadly is one reason why it is so difficult to combat.